Welcome to Unit 14.2, Ellipses. So within this section, we're going to be talking about ellipses, or also known as ovals. Now, ovals generally have one of two directions that they're generally going to face. They're either going to be vertical and be standing up, meaning the long vertex is vertical, or they will be horizontal. It would kind of look like a horizontal oval that would be laying on its side rather than standing up. Now, the most important part of this slide is that there is a such thing as a foci. Now, that is the sum of the distances from two fixed points. And we're going to go further into that within the upcoming slides. Now you can see the focus 1 and focus 2 dots there. Now keep in mind, as we start to talk about multiple focus, it would actually be called a foci, which is the reason why when we start talking about the foci of an ellipse, we're referring to both points within it. Now, when we are looking at standard form of one of our two equations, we are generally going to see it occur in one of those two ways. And that would be as x minus h squared over b squared plus y minus k squared over a squared. You would see it that way, or you would see x minus h squared over a squared plus y minus k squared over b squared. Now, this is extremely important to tell the difference between the two, and that would be the location of A. The location of A will tell us whether we are going to be looking at a vertical ellipse or a horizontal ellipse. The number one thing to always keep in mind is that A squared will always be greater than B squared. So this is the one easiest way to tell the difference between whether it's going to be vertical or horizontal, is to find the larger number and determine whether it is located underneath the y or underneath the x. In slide 4, we begin to talk about the differences between your vertical ellipse and your horizontal ellipse. Now, in this case, you can easily see that as we look at the overall shape of the ellipse, everything remains the same. It is just the orientation of the ellipse that rotates, meaning your long side or your major axis will always be the long side, and that will be the vertex or major axis, and that is going to be considered your long side. You are also going to have a co-vertex or minor axis, and that is going to refer to your short side. Now, whether you are looking at your vertical ellipse or horizontal ellipse, you can always see that the long side is your vertex and the short side is your co-vertex. Now, as we start looking at this next slide, there are a couple different things that we need to focus on. The first thing would be that we need to realize that we're going to be taking a look at three letters. We're going to be taking a look at A, B, and C. Our A, B, and C refer to different things and you need to be able to tell the difference between each one. A is the distance from the center to the vertex, B is the distance from the center to the co-vertex, and C is the distance from the center to the focus. Now, let's first begin with finding the center itself. Keep in mind, as you're working the center, your X as a whole, if we take a look at the middle line, notice both of your X's have 1, which means your center will also have a 1 because it is on that same line. When we look left to right, notice both numbers have a -2, which means that center would also have a -2. We are going to begin with finding the distance from the center to the vertex. Considering how we're at 1, -2, and we're going to 4, -2, the distance from 1 to 4 would give us a numerical value of 3. When we're taking a look at the co-vertex, we're looking at the -2 to 0, which would be a distance of 2. The distance from the center to the focus would be determined by a specific equation, and you calculate that by using this specific equation, and that is c squared is equal to a squared minus b squared. In this case, we've already calculated what a is. A is 3, which means 3 squared minus 2 squared is equal to c squared. C squared is equal to 9 minus 4. C squared is equal to 5. And to solve for c, we need to get the square root of both sides. Once you have the square root of 5 on both sides, what's going to happen is we're going to go ahead and also determine what the point of the focus would be. Now we know that we are starting off at the center, which is 1, and the distance from the center to the focus would be square root of 5. So our point here would be 1 plus the square root of 5, and it would be at -2, while the focus on the left-hand side would be 1 minus the square root of 5, -2. Keep in mind, the focus will always be on the same line as the vertex. And this is extremely important because as we are given different sets of information, it will help us determine the orientation of our problem, or of our ellipse. So let's go ahead and try to create an equation based off of what is going on within this problem. First thing would be to go ahead and write down your x's and y's. In this case, you have x minus h squared plus y minus k squared is equal to 1. Now remember, the determination of where your a is, whether it's underneath the x or the y, will give us whether or not it is vertical or horizontal. The fact that the ellipse that we're looking at is horizontal would mean that we would have our a squared underneath x minus h, and b squared underneath the y. What you would do is you would go ahead and plug in the values that you have for this equation. This would be x minus 1 squared over a squared. Now remember, a is 3, which means this would be 9, plus y minus k, or y minus a -2, which is y plus 2, squared over b squared, which is 4 is equal to 1. That would be the equation for this current ellipse. In slide 6, we go ahead and we start comparing the differences between our vertical ellipse and our horizontal ellipse. Now, the numeric value does not change when we are talking about the positioning of a vertex or a co-vertex or a focus. But what does change is whether that number is going to be in the position of the x or the y. As you can see for the vertex on the right-hand side, because we are moving left and right across that vertex, we are actually on the x-axis, while on the left-hand side, if we're talking about the vertex, because it's on a vertical line, it would move up and down based off of your y rather than your x. So once again, to find the foci, you would go ahead and use c squared is equal to a squared minus b squared. And anytime that you have the a underneath the x, that would give you a horizontal ellipse. If you have the a underneath the y, that would give you a vertical ellipse. Let's go ahead and take a look at slide 7. In slide 7, before we even begin anything else, what I want you to do is take a look at the actual equation. The fact that 16 is your larger number would mean that this is your a squared. And this would be your b squared. Now, the fact that your a is within your first column underneath the x, that would mean that this would be horizontal. Your a would be equal to 4, your b would be equal to 2. Your foci would be c squared is equal to 16 minus 4. C squared is equal to 12. C is equal to the square root of 12. Now we would go ahead and start plugging in what we know. We know this is going to be a horizontal ellipse. We are going to go off of the fact that your center is going to be 0, 0. Your vertices, remember, that's going to be the longer side of your ellipse, will be based off of knowing the center and knowing how far to the right or left it will go. In this case, we are going a distance of 4 to the left and right because that would reflect your vertices. Your co-vertices would be reflected by your B. So the 2 points for your vertices would be negative 4, 0, positive 4, 0. And your co-vertices would be 0, negative 2, and 0, 2. Now the length of the major axis, remember that is your vertex. If we are going from negative 4 to positive 4, that is a distance of 8. And if we're going from negative 2 to positive 2, we would be looking at a distance of 4. Our foci are based off of the square root of 12. Keep in mind that you would, instead of using your center, we have to remember that the center is 0, 0, which means we would have a negative square root of 12, comma 0, and 12, square root of 12 over 0. So notice we're looking at a positive and negative value. Once you have this, you would go ahead and graph everything out. Keep in mind, we're starting off at 0, 0. Our first point would be at positive 4, negative 4. Our co-vertices would go up to 2 and down to 2. Now, once you have everything set up, you can go ahead and draw your graph. Keep in mind, we still have to draw the foci of this problem. Now, if we're looking at the foci being at negative square root of 12, keep in mind, the negative square root of 12 is going to give you a specific number. Keep in mind, it's between 9 and 16, which means we would end up somewhere between 3 and 4. And that would be the completion of this problem. Let's take a look at slide 8. In slide 8, once again, we are noticing that our a squared would be on the right-hand side underneath the y. B squared would be underneath the x. In this case, we are looking at a vertical ellipse. Our center would still be 0, 0. We need to determine our A, our B, and our C. A would be 6, B would be 3, and C would be C squared is equal to 6 squared minus 3 squared. So C squared is equal to 36 minus 27. C squared is equal to 9. Actually, 9 would be 3 squared, which would leave us with 27. The square root of 27 would be C. So the distance between our vertices is going to be a distance of A, which is 6. So you're going up to 6, down to 6. You're also going to go ahead and go in the distance of B, which is 3. So to the right 3, to the left 3. So we go ahead, set up our graph just to be able to match up with what we're working with. And we are all set. Keep in mind, our center would be at 0, 0. And the foci would be A squared minus B squared is equal to C squared. We're looking at the square root of 27. Remember, that's going to be in between the square root of 5 and the square root of 25. In this case, 25 would be your better answer. When it comes to it being closer to the square root of 27. So we're going to be slightly above our 5 number. You would go ahead and mark that off, slightly above 5. That's where our foci would be. The vertices for this problem, considering how we are moving a total of 6, would be 0, -6, and 0, +6. Now the reason for this switch is because now our ellipse is vertical compared to horizontal. Vertices, we're going to be going to 3, so -3, 0, or +3, 0. For the length of the major axis, you're looking from -6 to 0 to +6, which would give us 12. And the minor axis would give us from -3 to 0 to 3, which is 6. So the foci itself would be 36 minus 9. Square root of 36 minus 9 is going to leave us with 27. Now the foci are a distance of square root of 27, which means just slightly larger than R5. So if you have to write this down, this would be square root of 27 and you would go ahead and find that other additional part. Now keep in mind, we know that it's going to be on the same line as our axis. So it's truly depending on you as far as where you're starting on that number. Now, something to keep in mind for this problem is that you always want your answer to equal 1. There are times where it may be better for you to work with a different equation than the one that you're using. Highly suggest going ahead and taking a look at the problem itself, seeing if you can figure it out, and have a stronger foundation of what we're covering. So in this case, what we're going to want to do is divide by 100. In this case, 25 divided by 100 would leave us with x squared over 4 plus y squared over 25 is equal to 1. Here we can tell that our equation as a whole is going to be vertical, and the main reason for that is because it is in that B slot. So that would be 24,000 Now, let's go ahead, solve for our different letters. In this case, A would go ahead and mean 5. 4 would be 2. In this case, we're going to get both sides of our vertex solved for the foci. So first thing would be horizontal or vertical. Keep in mind it's underneath the y, which means this would be vertical. Our center is going to be 0, 0. And the vertices, I will put it as 5, 3. Let's take a look at the amount of time that you stay. Now, for the co-vertices, remember you're looking at B, so you're looking at 2, 0, or -2, 0. Now, the length of the major axis, keep in mind, would be based off of what's the longest side. So in this case, the longest side of our major axis would be the 5 number, which in this case would be A. For the minor accident, we're going to be looking, or the minor axis, we're going to be looking at 2. If you're looking at the foci, remember that's going to be 0, comma, square root of 21, and 0 times square root of 21. Slide 10. We're going to first take a look at our equation and determine whether this is going to be horizontal or whether this is going to be vertical. Because our A, which is our larger number, is located on the left-hand side, we know that this is going to be a horizontal ellipse. We know that 0, 0 will be our center. We need to find our A, B, and C. So the square root of 169 is 13 for A, and it's going to be 8 for C. As we plug this into our equation, C squared is equal to A squared minus B squared. C squared is what we are finding. It's equal to 169 minus 64. Once you subtract those two numbers, you're going to end up with C squared giving you 105, and C would be equal to the square root of 105. From there, the fact that we know that it's a horizontal ellipse, we're starting off at 0, 0, and we're going a distance of 13 to the right. That would place us just about here and about there. We're looking at B being a distance of 8. And our foci would be the square root of 105. Now keep in mind, at 100, we're looking at 10. So it's going to be slightly larger than 10. We go ahead, grab our graph, and set it to our equation. So let's take a look at the points of our vertices. Our vertices is the long axis, which means that we are looking at 13, 0 and negative 13, 0. Co-vertices would be 0, negative 8, 0, 8. The major axis would be from negative 13 to 0 to 13, which would be 26. The minor axis would be from negative 8 to 0 to 16. Our foci would be at positive and negative square root of 105. So this would be square root of 105, comma 0, and negative square root of 105, comma 0. Slide 11 goes over the various things that we have talked about and how they change from a vertical to a horizontal graph. keep in mind the location of each one and whether it's going to be in the X or the Y position, depending on where and what type of ellipse we're looking at. Let's take a look at slide 12. Here it says, write an equation for an ellipse for the given foci and co-vertices. The first thing to understand is that the vertices itself and the foci are going in the same line the entire time, which means if we go ahead and take a look at our foci, this is our X and this is our Y. This means that it's going to be moving left and right. So our entire equation is, or our entire graph is going to be horizontal. From there, we go ahead and start finding our different values. In this case, we don't know what A is, but we don't know what B is. B is going to be 8. C is going to be 5. In order for us to find A, we have to go ahead and say C squared is equal to A squared minus B squared. C squared would be 25 is equal to A squared minus 64. You're going to go ahead and add 64 to both sides. A squared is equal to 89. And that right there is going to be our A squared. So A is equal to the square root of 89. So we're going to go ahead and create our equation from this point. So we know that if A is the square root of 89, we know that A squared is equal to 89. We know that B squared is equal to 64. And that's how we set up our equation. We have X squared over A squared. And we know A squared is going to be there because we are looking at a horizontal foci, plus Y squared over B squared, which is 64, is equal to 64. Sorry, not 64, 1. We replace to create an equation, so X squared is equal to 89, or X squared over 89, plus Y squared over 64 is equal to 1. This would be our equation for that given equation. Let's take a look at slide 13. In slide 13, we're doing something very, very similar, where we're going ahead, we're going to lay out our equation no matter what, and kind of go from there to determine whether it's going to be vertical or horizontal, and how that equation would look. So first thing, let's go ahead and take a look at the foci. The foci is in the X position, which means that we're going to be moving left and right, and that this top equation is horizontal. From there, we're going to go ahead and write down our equation so that it makes it easier for us to write it down later on. So X squared over Y squared over is equal to 1. Now remember, if it's horizontal, your left side, your A squared, will be longer than your B squared. So in this case, we're going to go ahead and we're going to grab the values that we need to determine our a squared, c squared, and b squared. So let's go ahead, begin with our covertex. Covertex says that it's going to be a distance of 2. So that means b is equal to 2, which means b squared is equal to 4. C squared is coming off your foci, which is 5. C squared would be 25. We can go ahead, plug into our equation. C squared is equal to a squared minus b squared. C squared is 25 minus 4, which is 21. C would be equal to the square root of 21. Now, that it would be if we were plugging in for A. In this case, we are searching for A. So, as we switch up our numbers into the correct places, A squared is being found. C squared would be 25 minus b squared, which would be 4. You're going to move the 4 over to the left-hand side, end up with 21 is equal to a squared. A is equal to the square root of 21. Correction, we're adding 4, not subtracting 4. So this would be 29. So once we go plugging in our values into this equation, we would have x squared over 29 plus y squared over 4 is equal to 1. Let's go ahead and work the next problem. Our next problem, we go ahead, write our generic equation of x squared over plus y squared over is equal to 1. We take a look at the foci. Notice it is in the y position, which means our entire ellipse is going to be vertical. If it is vertical, that means that it's going to be a squared underneath the y and b squared underneath the x. We have our A, B, C. Keep in mind the foci would be 5. Our covertex would be 1. And we're solving for A. If we're looking for A squared, B squared, and C squared, this would be 25, 1, and we're still solving for that. We're going to go ahead. C squared is equal to A squared minus B squared. Here we're searching for A squared. C squared would be 25. Is equal to A squared minus 1. We're going to move over the 1. 26 is equal to A squared. And now we can plug into our equation. So this is going to be y squared over 26 and x squared over b, which would be 1. Our last equation kind of goes over how to write the equation into standard form. This is going to be very similar to what we were doing before. First thing we're going to do is separate our x's and our y's. In this case, 8x squared is by itself. Y squared minus 6y is by itself. And minus 7 is going to be by itself. Now we're going to move that minus 7. We're going to add 7 to both sides. Now, we're going to have to complete the square for this problem. We're going to go ahead and grab b, which is negative 6, divided by 2, which is negative 3, and squared, which is a plus 9. We're going to add that 9 to both sides. Once we're there, we're going to go ahead and rewrite the entire equation. So 8x squared plus y minus 3 squared is equal to 16. Our entire goal is to make that number equal 1. So we're going to divide all of our sides by 16. When we do that, we're going to get x squared divided by 2 plus y minus 3 squared divided by 16. And this out here would be giving us a 1. Considering the placement of the 16 and the larger number, this would be a vertical equation. Let's go ahead and take a look at the next problem. We're going to do the same thing, separate our x's and y's. Here we have x squared minus 4x. We have 9y squared minus 36y. And we're going to add 41 to both sides. We need to find our completing the squares. 4 divided by 2 is 2. Squared would be 4. So we would have x minus 2 squared. In the case for 9, we're going to be able to take out a positive 9, and we're left with y squared minus 4. Now, from here, we can actually create our completing the square. Grab b, which is negative 4, divided by 2, which is 2, or negative 2, and we square, which is 4 once again. So we're going to add 4 here. Keep in mind, when we add a number to our problem, we also have to add it to the opposite side. So when we added 4 here, we would have to add 4 there. When we added 4 here, we're going to add 4 here. Now, keep in mind, on this right side, even though we said we are going to add 4 from the x, when it comes to the y, remember you have to multiply the 4 that you got times the 9 that's on the outside. That would leave you with a positive 36 for the right side. You're going to rewrite the problem as x minus 2 squared plus 9 times y minus 2 is equal to 81. Now we have to get that 81 and all the other parts to 1, which means we're going to divide everything by 81. As you can see on the right-hand side, this is going to give you 1. 9 and 81 is 1 and 9. So we're going to have y minus 2 over 9. And the last part would be just having x minus 2 squared over 81. Keep in mind, the fact that x underneath it is an 81, that would make this a horizontal problem. If you have any questions, please feel free to email me at any point.